The darkness between the stars is not empty. For millennia, humanity gazed into that profound blackness, seeing only a void, a sterile chasm separating worlds. We perceived the cosmos as a series of isolated islands of light, each solar system a ship in a bottle, sealed and solitary. This perception, this fundamental assumption of our loneliness, was a comforting lie, a story we told ourselves in the face of infinity. And like all profound illusions, it was destined to be shattered. The first crack appeared in 2017, a fleeting visitor, a whisper from afar named Oumuamua. It was followed by a second, more familiar traveller in 2019 too, Borisov. They were anomalies, statistical ghosts that proved the impossible was real. The great interstellar ocean had currents, things could cross the void. But 2 points of data are merely a line, not a pattern. They were curiosities, the vanguard of a revolution yet to be confirmed. Then came the autumn of 2025. A new age of astronomy had dawned, silent and unseen by most. High in the Chilean Andes, on the summit of Cerro Pachón, a new eye had opened to the cosmos. The Vera C, Rubin Observatory, a titan of glass and steel, was conducting its legacy survey of space and time, its mission to create the deepest, widest movie of the universe ever made. Night after night, its colossal 3-gigapixel camera inhaled the sky in vast, sweeping gulps of data, searching for anything that moved or changed or flared in the dark. In early November, an automated alert system, an algorithm named Helio-Link, flagged a faint smudge of light, an object designated C 2025F3. It was one of thousands of such alerts triggered that week. A minor planet, a distant comet, another piece of local debris, or so it seemed. The software, however, noted something peculiar in its motion, a subtle, almost imperceptible deviation from the norm. Its trajectory was not the gentle, looping ellipse of a loyal subject bound by the sun's gravitational monarchy. This was the path of a rebel, an outsider. Its orbit was a hyperbola, an open-ended curve screaming of escape. This was not a return, it was a passage. The alert found its way to the screen of Dr. Aris Thorne, a postdoctoral fellow at a data processing center in Arizona. He had seen hundreds of these hyperbolic candidates before. Nearly all were phantoms, artifacts of incomplete data, comets from our own Oort cloud nudged onto peculiar paths. Yet this one felt different. The data points were crisp, the mathematics clean. The velocity was staggering, far beyond the sun's escape velocity at that distance. This celestial nomad was not falling into our solar system. It was crashing through it, a bullet fired from an unseen rifle countless millennia ago. A quiet current of excitement then, a surge of frantic communication rippled through the global astronomical community. Telescopes across the planet, and in orbit above it, swiveled their gaze towards the faint apparition. Each new observation, each refined calculation, only deepened the certainty. This was not a phantom. This was real. This was the third one. The third confirmed interstellar interloper in human history. The pattern was now undeniable. The age of interstellar astronomy had truly begun. NASA, coordinating observations from its orbital assets, prepared to release the first resolved images. The world waited. The press release landed on November 17, 2025. It was accompanied by a series of images from the James Webb Space Telescope. They were not spectacular in the way a vibrant nebula might be. They were subtle, profound, and paradigm-altering. Against a tapestry of impossibly distant galaxies, a single point of light, trailed by a ghostly ethereal haze, moved with cold, implacable purpose. It was reddish in hue like Oumuamua, but larger, more substantial. Spectroscopy revealed a faint coma, a tenuous atmosphere. Unlike the dry, rocky Oumuamua, this visitor was bleeding gas and dust into the vacuum awakened by the faint warmth of a star it had never known. It was named Aethel, an Old English word meaning noble or homeland, a name that hinted at its origins a testament to a place we would never see. To comprehend the significance of this arrival, we must first understand the journey. Imagine our solar system as a vast, ornate merry-go-round, spinning in a cosmic park. All the planets, asteroids, and comets are horses rising and falling but forever attached to the central pole of the Sunday. Their paths are closed loops, ellipses. They are members of the family forever bound by gravity. Now picture someone standing far outside the park across a continent. They flick a single remarkable grain of sand with incredible force. For thousands, perhaps millions of years, that grain of sand travels crossing plains, mountains, and oceans of absolute darkness. Finally, by sheer dumb luck, its path intersects our spinning merry-go-round. It doesn't join the ride. It streaks through between the wooden horses in a near straight line, and then exits on the other side, continuing its endless voyage. That grain of sand is Aethel. Its hyperbolic trajectory is the mathematical proof of its foreignness. It is not one of ours. It is a momentary guest on a journey that began long before Earth had cooled and will continue long after our civilization is dust. Its composition only deepens the enigma. The light from Aethel, dissected by powerful spectrographs, tells a story of its substance, a chemical fingerprint of its distant birthplace. The initial readings were bewildering. It showed the spectral signatures of nitrogen ice, but in quantities and isotopic ratios, unlike anything found in our solar system. Isotopes are different flavors of the same element, with more or fewer neutrons. Their relative abundance is a unique marker of a star system's origin, a product of the specific supernova that seeded its primordial cloud. The isotopic ratios in Aethel were fundamentally alien. Imagine a master baker famous for a particular kind of cake. You know their recipe intimately, the type of flour, the source of the sugar, the specific variety of vanilla. One day, a new cake appears in your kitchen. It looks familiar, shaped like a cake with frosting and sprinkles. But when you analyze it, you find the flour is ground from a wheat that grows only on another continent. The sugar is derived from a plant you have never seen. The vanilla is an entirely different species. The cake is recognizably a cake, but its fundamental ingredients betray a completely different origin, a different pantry, a different world. This is the mystery of Aethel. It is a celestial body, a cometary object, yet its building blocks were forged in the crucible of a star and a protoplanetary disk light years from our own. It suggests the existence of a frigid Pluto-like world, orbiting a distant unknown sun, a world whose atmosphere was stripped away by some ancient cataclysm, sending frozen fragments of itself careening into the galactic wilderness. This visitor does not arrive in a vacuum of knowledge. It follows in the footsteps of its enigmatic predecessors, each of which rewrote our understanding of the cosmos. We must travel back to 2017 to the discovery of one eye, Oumuamua. The name is Hawaiian, meaning a messenger from afar, arriving first, and a strange messenger it was. Detected by the Pan-STARRS telescope in Hawaii, it was already on its way out, having slingshotted around the Sunday. It was small, perhaps, only a few hundred meters long and astonishingly elongated like a cosmic cigar or shard. Its color was a deep dark red, the result of eons of cosmic ray bombardment that had cooked its surface into a complex organic crust. But its most baffling characteristic was its movement. As it sped away from the sun, it was accelerating. Something was giving it a gentle, persistent push, defying the simple laws of gravitational mechanics. For comets, this is not unusual. As they warm up, ice sublimates into gas, creating jets that act like tiny rocket thrusters, a phenomenon called outgassing. Yet astronomers looked at Oumuamua with every tool they had, and they could see no tail, no coma, no hint of outgassing. It was accelerating without any visible means of propulsion. This discrepancy opened a chasm of speculation. Mainstream science proposed theories of invisible outgassing, perhaps pure hydrogen ice, or a solid nitrogen iceberg fragmenting. These ideas were plausible but pushed the boundaries of known physics. It was an unsatisfying answer to a profound riddle. Into this void stepped astronomer Avi Loeb of Harvard University. He proposed a more radical, more electrifying possibility. What if Oumuamua was not a natural object at all? What if its strange shape and anomalous acceleration were signs of artificial construction? Perhaps it was a probe, a derelict piece of technology, or even a solar sail impossibly thin and designed to ride on starlight. The suggestion was explosive, drawing both fascination and fierce criticism. Most scientists argued that natural explanations, however exotic, must be exhausted first. But the seed had been planted. Oumuamua left us with a haunting question mark hanging in the cosmos. It was the ultimate alien, a puzzle that came and went too quickly to solve, leaving behind only tantalizing ghostly data. Then just 2 years later came 2I, Borisov, discovered by amateur astronomer Gennady Borisov from his backyard observatory in Crimea. This second visitor was a completely different beast. Where Oumuamua was strange and inscrutable, Borisov was reassuringly familiar. It was for all intents and purposes a comet. It had a visible coma and a broad, dusty tail. It outgassed as it approached the sun, just as a comet should. Spectroscopy showed it was rich in carbon monoxide and water, not so different from the comets born in our own solar system. Borisov was the ambassador, the diplomat. It told us that the chemistry of planetary formation, the ingredients for worlds, might be remarkably consistent across the galaxy. It was a message of cosmic unity. But it also highlighted just how bizarre its predecessor truly was. If Borisov was the norm for interstellar comets, then what in the universe was Oumuamua? For centuries, even before we saw them, we knew they must exist. Thinkers from Laplace to Isaac Asimov reasoned that if stars form planets, and if planetary systems are dynamic, violent places, then the process of creation must be messy. Planets migrate orbits, cross gravitational tugs of war between giant worlds must eject smaller bodies with tremendous force. Our own solar system was once a chaotic shooting gallery. Computer models show it likely threw out trillions of comets and asteroids in its youth. These celestial orphans, cast out from their homes, were destined to wander the galaxy for eternity. The galaxy should be teeming with them, a faint, invisible mist of interstellar flotsam and jetsam. The mystery was not that they existed, but why it took us so long to see them. The answer lies in their speed and their darkness. They are small, they are fast, and they reflect almost no light. Finding one is like trying to spot a lump of coal in the dead of night from 100 miles away as it flies past at 50,000 miles per hour. It was an impossible task until now. The arrival of Aethel signals the end of this era of blindness. It was found not by chance, but by design. The Vera C. Rubin Observatory is a machine built to chart the transient universe. Its 8.4-meter mirror and its vast camera, the size of a small car, are a net designed to catch these fleeting interstellar fish. Unlike previous surveys that scanned small patches of the sky, Rubin scans the entire visible hemisphere every 3 nights. Its sensitivity is so extreme it could detect a candle flame on the moon. Its data processing pipeline is an artificial intelligence marvel sifting through petabytes of information in near real time. Oumuamua and Borisov were lucky finds. Aethel is the first of an expected flood. Astronomers predict that within the first few years of its operation, the Rubin Observatory will discover not one or two but dozens, perhaps hundreds of interstellar objects each year. We are standing at the threshold of a new field of science. We will move from anecdote to statistics. We will build a catalogue of visitors from other stars. Each new object will be a core sample from a different part of the galaxy. By studying their compositions, we can begin to map the chemical diversity of star systems beyond our own. We can ask, how common are water-rich bodies like Borisov? How common are rocky processed fragments like Oumuamua? How many are nitrogen icebergs like Aethel appears to be? The answers will revolutionize our understanding of planet formation. They are in essence a free interstellar sample return mission delivered to our doorstep by the patient hand of gravity. The discovery of Aethel so early in its approach has also reignited a long-held audacious dream, an intercept mission. With Oumuamua, we saw it only as it was leaving already out of reach. Borisov was also detected too late for any credible chase. But Aethel is different. We have found it with years of lead time before it reaches its closest approach. This presents humanity with a tantalizing historic opportunity. Could we send a probe to meet it, to fly alongside it, to photograph it in stunning detail, to analyze its coma, and perhaps even to land on it? Projects like the European Space Agency's Comet interceptor are already being designed for such a possibility. The concept involves a probe parked in a stable location in space, waiting patiently for a suitable target to be identified. When a visitor like Aethel appears, the probe would be launched on a high-speed trajectory to rendezvous with it. The technical challenges are monumental. The speeds are extreme, requiring immense energy for the launch and for braking to match the object's velocity. The encounter would be brief, a fleeting flyby measured in hours or minutes, but the scientific return would be incalculable. To touch, to taste, to analyze a piece of another solar system would be a feat comparable to the Apollo missions. It would be the first time humanity has ever made physical contact with an object that was not born of our own Sunday. The implications of these silent travelers extend beyond planetary science, touching upon one of the most profound questions we can ask: are we alone? For over a century, the theory of panspermia has lingered at the fringes of respectable science. The idea posits that life itself, or at least its essential building blocks, might not have originated on Earth. Instead, it could be transported through space, hitching a ride on comets or asteroids, seeding fertile worlds as they pass. These interstellar objects are the perfect vehicles for such a process. Their interiors are shielded from the harsh radiation of deep space. Their journeys, though long, are spent in a deep freeze, perfectly preserving any complex organic molecules they might carry. If a visitor like Aethel were to be analyzed up close and found to contain amino acids, lipids, or even more complex structures, it would lend powerful new evidence to this hypothesis. It would suggest that the universe is not a collection of sterile islands, but a vast interconnected ecosystem where the seeds of life are constantly being exchanged. It would mean that life on Earth may not be a singular miracle, but a local flowering of a galactic garden. This is the ultimate promise of these messengers from the dark. They are transforming the cosmos from a static diorama into a dynamic living entity. The space between the stars is not a barrier, it is a highway, and along that highway the history of the galaxy is flowing. Each wanderer is a message in a bottle carrying a story of its creation of the star it once called, home of the cataclysm that set it on its path. Oumuamua was a riddle, a whispered secret we could not decipher. Borisov was a friendly greeting, a note of cosmic kinship. Aethel, this third visitor, is the confirmation of a new reality. It is the herald of a great migration, an endless stream of silent pilgrims drifting through the night. They have been passing by for billions of years unseen and unnoticed. Their arrival in our awareness is not a change in the universe, but a change in us. Our eyes are finally open wide enough to see what has always been there. We are no longer merely looking out at the universe. The universe, in its own slow, methodical, gravitational way, is now coming to us. It is sending us samples, pieces of itself from shores of unimaginable distance. The arrival of Aethel is more than a scientific discovery. It is a moment of profound philosophical realignment. It dissolves our sense of isolation. It weaves our small blue world into a galactic tapestry of unimaginable scale and complexity. We are connected not by signals or language, but by matter itself. The dust of a distant dying star frozen into an object like Aethel can, after a journey of 1,000,000 years, cross paths with our own world. The cosmos is a place of profound solitude, yet we are, it seems, all made of the same wandering star stuff. And now we know for certain we occasionally share it. The darkness between the stars is not empty. It is full of stories waiting to be read.